So let's practice diagramming the knee-jerk reflex. If you were to do this, you would have a hit to patellar ligament as your stimulus. The rest of this, and then we'll check it, and we'll do the next step that I briefly want to talk about with the patellar reflex. So here are those components of the knee-jerk reflex itself. The femoral nerve being both the sensory and the motor neuron. The nerve is composed of multiple axons, multiple neurons. L2 through L4 is the regions of the spinal cord involved. Quadricep is your effector or target, and the response is that it contracts, which then results in that kick. I want to use this as a way to branch into polysynaptic reflexes. So this itself, the knee jerk, is a monosynaptic somatic ipsilateral reflex. However, when this occurs, there's also a polysynaptic piece that happens as well. So remember, our polysynaptic, that looked like this, where there is integration of two synapses that occur. So you've got an interneuron in the spinal cord. This interneuron in the spinal cord is really the key part that makes it a polysynaptic reflex. And in reality, there is polysynaptic activity going on with the knee-jerk reflex. What would be affected? So the monosynaptic is your quadricep contracting. What else might happen when your quadricep contracts? Well, the antagonistic muscles might relax. They do. These are the hamstrings. Those are going to relax to allow for this kick to be larger. So this is what that looks like. Same picture you've seen, right? Different actual image. Here's the muscle spindle, quadricep, within the quadricep, sensor information going to the spinal cord. This is our monosynaptic reflex that we just went over that's causing the quadricep to contract. So this is going to the quadricep itself. Notice that red. We've also got, though, another guy here. This interneuron is changing this plus to a minus by being there. So what might this plus be? Acetylcholine is what it is, or GABA. I'm sorry, glutamate. Those are the two excitatory neurotransmitters we've talked about. So let's say glutamate, and let's put an arrow to this positive right here. And let's make that a little bit darker. So glutamate is a common excitatory neurotransmitter. What might this green neuron release? It might release GABA. GABA is an inhibitory neurotransmitter. If you've got a GABAergic or a inhibitory interneuron in here, you're going to have a change from the more that interneuron is stimulated, the more it's going to inhibit the neuron it's talking to. So the blue neuron here, this blue alpha motor neuron, is turned off. You can't actually cause a muscle to relax other than inhibit its contraction. So the green neuron is an inhibitory interneuron. The more it's stimulated, the more it turns the hamstrings off and prevents them from flexing the leg. Instead, the leg will extend when those quadriceps contract. Red, motor, efferent, activates the quadriceps. Green is inhibitory to the motor efferent. It inhibits the purple. This idea of inhibiting, exciting something, inhibitory. This is how it's set up, right? We've got inhibitory, excitatory synapses turning each other off and on throughout the entire body.